I mean the lab procedure that you need to do will be on 7 labs, okay, and then the rest of that will be the tutorial. So it will be a mix up of tutorial and also the laboratory session. So basically the laboratory session, so because it involve online, so most of that I mean the will involve simulations and also um, the experiments that probably you can do that at your home. Okay, so but for today's session, our first lab session will be the tutorial. Okay, so I'm giving you out the tutorial questions in a few minutes. Okay, and then I'm gonna help you throughout or the first 1 hour and the rest of the lab session, so you can do that by your own. All right, so as we already learned yesterday, okay, so we already learned about the units, all right, conversions between the units, okay, and then about the vectors as well. So that's basically what is covered in the first topic of the tutorial. Okay, so give me few minutes to sort out the tutorial question to be given out to you. So I'm going to share that on the WhatsApp group, and then we're going to look the problem together, okay, one by one, and then basically um, I won't give you the exact solution to that, because you can actually you need to figure out how to do that, but I'm going to give you the answers. All right, I'm going to give you the answers so you can um, answer that tutorial, right? You can check that through whether you did it right or wrong. Okay, so give me a few minutes. Okay, so I already shared that. So you can download it on the WhatsApp. So basically today we're going to solve the problem on the chapter 1. Okay. So as yesterday's lecture, so I haven't finished all of that. I mean, of the chapter 1. So I'm going to finish it by Thursday. All right. So after that, you can complete the chapter 1 tutorial. All right. So basically, this tutorial 1 consists of chapter 1 until 4 on the book. Okay, so basically there are 4 questions. But I'm going to ask you to submit the chapter. All right. I'm going to ask you to submit the chapter by one by one. All right. So meaning that for today's lab, you need to submit chapter 1. All right. And then later, once we finish with another chapter, chapter 2, chapter 3, and chapter 4, so you need to submit that subsequently. All right. So for this chapter 1, so for the question 1.46 and 1.51, so that one haven't been taught during the lecture. So basically, you can neglect those 2 questions first, and then you solve the rest of that. And then after I finish with chapter 1 on Thursday, then you can complete those 2 questions. And then you can do the submission. All right, you can do the submission by next week. Okay, so the instruction is clear.
Yes.
Okay, doctor.
Okay. Okay, so all right, so we will look at the first question, which is the density of gold is 19.3 gram per cm cube. All right, so what is this value in kilograms per cubic meter? So let me share you my screen. Okay, so we are looking at the first question. Okay, it should be simple, all right? So basically, you need to change the unit from gram to kilogram and centimeter cube to the meter cube. Okay, so who got the answer? Okay, I'm giving you 2 to 3 minutes to solve that, and then I'm going to ask you to give me the answer. All right, and then we'll check together. So whether what you did is correct or not. Okay. So if you have any concern, you can speak it out. All right. So by the time, right, if you have any question, you can ask. So I give you 2 to 3 minutes to solve this question, because the first one is relatively easy, so it's not a big deal. So actually you can just follow one of the, actually there was one example in the slide that I shared yesterday, so the step was there, so you can just follow that, and then I'm going to know what is the answer from you. Okay, so any of you have got the answer? Okay, I'm gonna ask Lim So Sim. So what's the answer? Lim?
Um, I'm not sure I'm correct, but I found it.
It's okay. If it's not correct, we can go through together. So we just want to know, I would just want to what's the answer from you first, and then if many of you got the wrong answer, then we will go together. Okay. So what's the answer?
19. I, I got 19,000.
What is it? 19?
19000.
190. Where's your 3?
Oh,
If you be 193, right? 193.
19300.
How
And
many zeros?
2.
2. 1, 2, 3, 4. Yes, that's correct. But the way that you should write it, okay, is in terms of significant figures like 1.93 times 10 to 4, okay, kilogram per meter cube. Okay, so that's the how should you write the answer. So 1.93 times 2, 4 kilogram meter cube. So anyone hasn't got the answer like that, can let me know. I'm going to share you the answer. Give me a few seconds. Okay, so the answer is 1.93, okay, times 10 to the 4 kilogram over meter cube. So who haven't got the answer like this? Okay, so since you are quiet, so I guess everyone can get the answer correct. Okay. All right, now we move on to the second question. Okay. So this one, get a certain fuel efficient. So a certain fuel efficient car gets gasoline mileage of 55 miles per gallon. All right. A, if you are driving this car in Europe and want to compare its mileage with that of other European cars, express this mileage in km per liter. Okay, so basically, it is similar like question number 1.4, all right? So now you need to convert that from miles to kilometer and gallon to liter. Okay, so you need to express that. So everyone got the conversion correct for miles to kilogram. Okay, so what's the conversion from miles to kilogram? So how many miles for every kilogram, or how many kilogram for every miles? Okay, Siti Balkis. All right. So what's the unit of the conversion from, let's say, 1 kilogram to how many is equals to how many miles?
1 mile is 1.6 kilometer.
Okay. All right, so that's correct. So, right, do the conversion and then, okay, one more, gallon to liter. So, Akil, so how to convert gallon to liter? Akil,
3.78, Doctor.
0.78.
3.78.
Okay, 3.78. Okay, that's correct. So it's actually 1 gallon is equals to 3.788. So 3.788. Okay, so it's double eight, right? But if you want to use 3.78, you need to use 3.79 because if you are using two significant figures, you need to round up the third one, right? So, but now you are using for four significant figures, all right? So you have 3.788 liter. Okay, and then for the kilometer, so I suggest you to use 1 mile equals to 1.609 kilometer. Okay, so as Balkis said before, so we have 1 mile equals to 1.6 kilometer. So try to use up to four significant figures. So usually in the physics, the good significant figures is from 3 to 4. So if 4 is available, yeah, then you can use 4. So here 1 mile is equals to 1.609 kilometer and 1 gallon equals to 3.788 liter. Okay, so do the calculation. So who already got the answer? So you can raise your hand. I'm giving you, all right, 5 minutes to solve that because the question is relatively simple. It's like 1.4. Okay, I'm giving you 5 minutes to solve that. Okay, have you got the answer? All right. How about can you give me the answer?
23.36.
Okay. Right. That's good. So what's the unit? So the unit will be kilometer per liter. Okay. Thank you, Atika. All right. So everyone got the answer. So the answer is 23.36. So everyone got different answer? Okay, so I assume everyone got the answer correct. So we move to B. All right. So if this car gas tank holds 45 liters, how many tanks of gas will you use to drive 1500 kilometers? Okay. So you already know the mileage. So 23.36. Okay. So you need to drive over 1500. Okay, so meaning that, so how many liters is used? So you need to divide, all right? You need to divide that with 1500 with 23.36. So you will know how many liters is used by the car, all right? Okay, so what's the answer? 1500 divide with 23.36. No, Safia, what's the answer for that? 1500 divide, so divide with 23.36. So no, Safia, what's the answer? I'm just asking you about 1500 divide with 23.36. What's the answer for that? So, so when we are doing the tutorial, so I hope everyone is having their with all of you. All right, so it is easier for you to do the calculation. So what is it? Elia, Natasha?
I got 64.21.
Okay, all right, that's correct. And then it asks, okay, if the, so that 64.2, all right, so it cannot fit for one tank, all right, because one tank can only hold 45 liter. All right, so how many tank is used? So you need to divide, all right, 64.2, all right, with 45 liter. All right, so the answer should be 64.2 divided with 45. So how many tank is used?
2 tank.
Oh. Yes, actually you need to use 2 tanks, but to make it specific, you can say it is 1.4 times. Okay, so it is 1.4 times. Right, so that's the answer. So the answer is 1.4 times. Oh, 0.4 times. Okay, everyone got the answer?
Yes.
Okay, good. Okay, so we move on to the next question. So 1.11. So in the fall of 2002, a group of scientists at Los Alamos National Laboratory determined that the critical mass of Neptunium 237 is about 60 kilogram. Okay, so this is a nuclear physics study, all right? So it studies the mass, the mass of the Neptunium 237 is about 60 kilogram, and the critical mass of a fissionable material is the minimum amount that must be brought together to start a chain reaction. Okay, this element has a density of 19.5 gram per cm cube. What would be the radius of a sphere of this material that has a critical mass? Okay, so this question looks a little bit tricky. So how to solve that? Anyone got the idea? So you need to know, okay, so when there is a density, meaning that mass have got a volume, all right, it got a volume. So it says that the question says that the radius of the sphere of the material. So it is asking the sphere. So what's the formula for a sphere if you want to determine the volume of a sphere? What would be that?
Over 3 pi r.
Pardon? What's the volume?
4 over
4
3
over
pi
3.
r cube.
Yes, 4 pi r cube. Okay, 4 over 3 pi r cube. So V equals to pi over 3 r cube. So V equals to pi over 3 r cube. So everyone got that? Okay, so V pi over 3 r cube. Okay, so all right. So to solve that, sorry, 4 over 3. So it's 4 over 3. So 4 over 3 pi r cube. So that's V. Okay, 4 over 3 pi r cube. Okay, and then you need to know what is the radius. Okay, But first, you need to know what is the volume. So what is the relationship of the volume and density? Okay.
It's mass over volume.
Yes, mass over volume, you got the density. So it is so mass over volume is equals to density. Okay. So mass over volume, all right, is equals to density. So volume is equals to, okay, mass over density. So figure out what's the volume. All right. So you are given the mass already. So you are also given the density. So 60 over 19.5. So it's 3.08. All right. 3.08. So that's your volume. But first, that's not correct because you need first to convert 90.5 to kilogram. Okay. Kilogram over meter cube. Okay. So what's the unit in terms of kilogram per meter cube? So this actually similar to what is to the question of 1.4. All right. So you should have 1.9310 to the power 4. So that should be 60 divided 1.93, okay, to the power of 4. So what is your volume in the meter cube?
Betul 1.95 kan?
1 point,
1.95.
yes, 1.95. 1 or 1.9. Let me check the question. Yeah,
19.5.
yes, 1.95 10 to 4. All right.
Yes.
1.95 times 10 to 4. So 1.95 to 4. So what you get is 3.08 10 to minus.
Negative 3.
Okay, so that's in the meter. All right. So that's in the meter. Okay, so you get 3.08 times 10 to minus 3. Okay, in meter cube. So in meter cube. All right. So the radius. So you just plug in this V into that. Right. So plug in this into this. Okay, and then you need to figure out what is your R. Okay, so R. So what is your R? So R cube. So I need to insert the equation here.
16.69.
16 point.
7.
You mean R cube? You mean R cube?
I mean radius.
So what's R? What is the R?
0.09.
Let me
Okay.
calculate.
Okay, you got, yes, that's the answer is correct. So R is 0.09 meter. So which is 9 centimeter. Okay, so everyone got that? So
Yes.
okay, good. So R is
0.09.
0.09 meter or 9 centimeter. So that's your R. Okay, so R should be that. So this is your R. Okay, anyone got left behind? Anyone that still hasn't got the answer or confused to get the answer? You can raise your hand. Okay, so everyone is okay, right? Okay, so all right, we continue to the next question. So 1.39. All right, so vector A is 2.8 centimeter long and is 60 degree above the x-axis in the first quadrant. Okay, you are given the figure there, 1.39. Okay, you are given the figure. So you have the vector A there, and the magnitude is 2.8 centimeter, and it make a degree of 60 degree above the x-axis. Okay, and the vector B is 1.9 cm long and is 60 degree and is below the x-axis in the fourth quadrant. Okay, use the components to find the magnitude and direction of A plus B. Okay, so how to solve that? So A plus B. So yesterday you learned about ways on how to do the vector addition. All right, either you add tail, okay, or you can add tail to tail. All right, or you add, first you add vector B and then vector A. So that's the three ways on how to solve vector addition. Okay, so because you are given this set of problem, so the easiest way to solve that, how to do that? Okay, so you also learned yesterday about to solve that, the component of each of the vector. So actually you can know what is your ax and also ay, and also what is your by and also bx. All right, so you can also use that information to help you to solve the question. Okay, so right, so that's the way you should solve that. Okay, so basically, so you will have, okay, let me draw that. Um, Okay, so it might be not a straight line, but it is 90 degree. So I'm going to just show the component of that. So let's say that's your A. Okay, so basically, so that's your AX, and then you have here AY. Okay, so your vector A. Right, so you need to first find the component of that vector. All right. So what is your AX? So so your AX is
Cos
so
60.
yes, cos 60 A. All right, A cos 60. Okay, so you remember the cosine formula. All right. So
1.4.
okay, so adjacent side with the hypotenuse. Right. So AX is
Uh,
right 1.4 cm. And then how about
1.40.
so actually okay, so so your AX, okay, AX is equals to A cos 60. Right? So that's for AX. And inversely, AY is A 60.
Sin 60.
Okay.
2.42 cm.
Yes. So AY is 2.425 or 2.43. All right. So that's AY. All right. Do the similar thing with B component. All right. So you have BX and also BY. All right. So that's BX. And so what's the BX? Hidatul, you got that? So what's the BX?
0.95.
Yes, 0.95 centimeter. All right. So that's your BX. So BX is B cos minus 60. All right. B cos minus 60. Okay, so cos. So when we have cos minus 60, okay, or all right. So actually you can just take that component, all right? Or cos 60 is also similar. Cos minus 60 or cos 60 is similar, giving you similar 0.5. And then what is your sine 60? Sine 60 is also giving you the similar answer, right? So by 1.9 sine minus 60. So but remember that, so whenever there is a vector, so this is important, okay? When there is a vector, to know whether where is the direction of that component. So when the direction is going to the negative y-axis, so you should add minus in front of the magnitude. All right. So for by, the answer is 1.645. All right. So you should add minus 1.645. Okay. Is it clear?
Yes.
Okay.
Yes.
So okay, now we can now find what is A plus B. All right. So A plus B. So what would you have? So you have now, you can add AX and BX. So your AX now, so let me draw that. Okay, now you have AX and also you have, it's easier to draw using this. So you also have BX to that. And then, okay, to that. So now you already have okay, here is your AX over there, and then here is your BX, and then here is your BY. Okay. So now, let's say you mentioned that that's a C vector. So CX is AX plus BX. Okay. And then your CY is equals to AY plus minus BY. Okay, so that's the new vector. All right, that's the new vector. So what was our AY?
2.2.
2.4, right? 2.42, and then
2.42.
is 1.6. So AY is bigger. When AY is bigger, so the component will of the C will be on the positive y direction. Right? So what I meant is so your CY will be to that direction. Okay, not to this direction. So you have component of CY and CX. So now you can find what is your vector C. So C is A plus B. Okay, so that's your vector C. So first, what is CX?
2.35.
Okay, CX is the 2.35 and CY.
0.775.
Okay, 0 or 0.8. All right. So you need to find out what is C. C is the square root of CX squared plus CY squared. C is the square root of CX squared plus CY squared. So what's the C? C is 2 point,
2.5.
all right,
5.
2.5, and then you need to find out what is the angle. Okay, what is the angle of C? So because C is making an angle. So that because you are asked about the magnitude and also to the direction of C. So you already obtained the magnitude of C, which is 2.5, right? And then now the direction is how many degrees from the x-axis?
71.
No, not 71. So how do you find this angle? This angle, so you have,
18.8.
yes, that's correct. It is 18 point. So you use the tangent formula, right? So your so your CY is 7.78, all right, 0.78 divide with 2 point, so the CX component is 2.35, okay, and then inverse tangent of that is 18.3 or 18.4. So everyone got that? So basically this is the, okay, so theta, so tangent theta equals to CY over CX. Okay, so you need to solve for the theta. All right, the answer is 18.4 degree. Okay. All right, everyone got that? Or you have problem to obtain the answer? So if everyone is okay, so we can continue with B and C. All right, B and C. So since you already solved the component of A and B, so it will be easier. So you just, okay, so you just find out the X component first. So you need to find out what is your CX. So CX is equals to AX minus BX. And then for the Y component, so it is CY equals to AY. So minus, because B is also minus, so minus minus it is addition. So AY plus BY. Alright, so that's your C, Y. Okay, and then you can find out what is your C vector. So which is equals to A minus B. Okay, and C, so it is inverse of that. So you start with vector B first. So for the X component, it is not a problem. So because you just A and B. Sorry, for the, alright, so for the C, so B, because we start with B, okay, we start with B. So is it B is BX is smaller than AX, or BX is bigger than AX? So our BX is 0.95 cm, and our AX is 1.4. So BX is smaller than 1.4. Okay, so it would be a negative. It would be a negative of X component, right? Because BX is smaller than AX. So your CX will be negative. And then your Y component, so BY, all right, so BY is already, and then you minus that AY. So CY is equals to minus 1.645 minus 2.42. So, okay, 2.43. So you get around 4. All right, you get 4 something, minus 4 something for Y component. Okay, then after that, you find out what is the angle. Okay, similar way on how to solve for A. All right, so I'm giving you the answers, and then you need to solve the B and C, because I'm going to move on the last question. All right, 1.43. Okay, we already solved for A, and now for B, the answer is the magnitude of the vector C, A minus, is 4.09 cm. Okay, 4.09 cm, and then the angle is 83.7. The angle is 83.7. So for B, the vector C is equals to 4.09 cm for its magnitude, and then the angle is 83.7. 83.7 degree. Okay, so that's for B, and then for C, all right, so for C, because it is negative, all right, so because it is negative, but it is actually the same answer that B, so the magnitude is similar. Okay, the magnitude is similar, 0.409 centimeter and the theta. Theta is equals to, okay, so because your theta, it will be, so it will be like that, all right? So it will be here. So you need to find out what is the theta for that. So that's your theta. Okay. So your theta will be 264 degrees. Okay, 264. That's the answer for B and C. Okay, so try yourself for B and C. Okay, so we move on to 1.43. Right, give me 1 minute. Okay, we move on to the 1.43. So write each vector in figure 1.43 in terms of the unit vector I and j. Okay. All right. So I haven't taught you about unit vector. Right. I thought this question is already covered by yesterday's lecture, but never mind. All right. So you can neglect this one first. All right. So later you can complete this. I'm going to continue this All right, later we finish with the lecture. Okay. Hold on. I'm thinking of to cover it up a little bit because I think unit vector is not a it's not difficult. Give me few minutes to let me check the lecture notes. Okay, so today okay we stop. Okay, we stop at the finding components. All right. So okay, this is what we just did just now. So we can use the components of a vector to find the magnitude and direction. Okay, as we just solved, so we find this the Euclidean distance or the square root of ax squared plus ay squared. Okay, so you get the new vector. Okay, and then for the angle, so you just use the of tangent to find the angle that the new vector made with the x-axis. All right, so basically when you have the y component and also x component, so you can just simply find what is the theta. Okay, so for example, you have multiple components to be solved, so basically the summation will be addition of all x components and also addition of all y components, and then you can solve that. Okay, all right, so now it is a unit vector. So a unit vector, what is a unit vector? A unit vector is a vector, all right, with a magnitude of 1, and then there is no unit. Okay, the unit vector I, okay, points in the x direction, and then j points in the y direction. Okay, and the k points in the z direction. Okay, so every unit vector, okay, that is pointed to the x direction. Okay, as you can see in the picture. Okay, as you can see in the picture, so unit I points to x direction, unit vector j points to y, and then unit vector k, unit vector k points to the z direction. Any vector can be expressed in terms of its component. So a vector can be expressed in terms of any components. Okay, it has ax, so I plus ay, j, and ez, k. So that's all refers to the component according to the direction of that unit vector. So I is referring to the unit vector in the x direction, y the unit vector in the y direction, and z is the unit vector in the z direction. Okay, so that's describe the unit vector. Okay. Okay, so for the scalar product, so we have the dot. Okay, the dot is the scalar product. So A dot B. Okay, A dot B. Okay, so it is similar to AB. So you take the magnitude of A times B and then time cos phi. So phi is the angle between vector A and B. Okay, so you connect the tail to tail of vector A and B and then make the angle between that. So that's the phi. Okay, so this equation simplifies that. Okay, so all right, so for B, okay, you can also find out, okay, you can also find out from the drawing of the vector. So why it is cos phi? All right, it is because this component, all right, this component over here is b cos phi, which is the, it's like a bx. Okay, it is like a bx. So for example, a vector a is traveling to x direction. Okay, and then we need to find out what is the vector b in terms of vector a direction as well. So that's why it comes out with b cos phi. So you can understand that. So meaning that we are looking for the both vectors in the same direction dot product. Okay, is everyone is clear? Any question? Any question? Are you guys still with me?
No, doctor.
Okay. All right. Okay, so you can either solve like a B, or you can also solve like C. So where you find out the component of A, okay, onto the vector B. Okay, so basically, so you solve the component of A onto B, so you also obtain the similar answer. Okay, so for here, you multiply with the magnitude of B times A cos phi. So that's actually the two ways, okay, of two ways on how you obtain the AB cos phi, okay, for the scalar product. And then the scalar product can be positive, negative, or zero, depending on the angle between A and B. Okay. So let's say look at A. Okay. So if phi is between 0 and 90 degrees, A dot B is positive. Okay. Of course, it is positive because it is less than 90 degree. But now B, let's say vector B exceeds to the more than 90 degrees to the vector A. So now the B component will be negative, right? So because the BX component will be negative. Okay. So BX component is B cos phi. So because phi is less than 0, which is negative. Okay. And then one more case, if theta is 90 degree, okay, A dot B will be 0. Okay. Cos phi, okay, when cos phi is 90 degree, then it will be 0. Okay. In terms of component, when we do the scalar product A dot B, so we have AX BX plus AY BY plus AZ BZ. Okay. So that's the component for the dot product. If the scalar product of two vectors is the sum of the products of their respective components. Okay. So that's the definition of that. Now you want to find the angle using the scalar product. For example, 1.10 shows how to use components to find the angle between the two vectors. Okay, so for example like that. So it is a 3-dimension. So for example, A. So you have the vector A. So you look at here. Okay, so vector A actually can be translated into the I and K component, right? I and K component, and also to the J component. Okay, while the vector B, okay, can be translated. It can be translated into the vector K and I as well, and also the vector J. Okay. Now we are entering the vector product. So we have, when we are multiplying the two vectors, okay, we are actually finding the product of vectors. There is always only two cases. It is a scalar product or the vector product. Okay, scalar means dot product. Okay, but for the vector product, it's called a cross product. Okay, so for example, C is equals to A cross B. Then, okay, what is similar? C is AB sine phi. Okay, so when crossed, it is a sine. When it's a dot, then it is a cos phi. Okay, so the direction of the vector product can be found using the right hand rule. Okay, so we can use the right hand rule to solve for the cross product. Okay, we need to find out what is the vector C. How about the direction of that? So we can use the right hand rule. So if a vector A, so it is on the x plane, for example, it's on the x plane or on the vertical plane, on the horizontal plane. So both of that vector is on the horizontal plane, and then let's say A is to the minus y direction, and then B is between minus y and minus x direction. So you can take the angle from A to B and then use the right hand rule. So your vector C will be pointed up, right, to the north. Okay, so that's how you can determine the direction of the resulting vector from A cross B. So how do you know it is going downward? Okay, now you know it's going upward. Okay, so when it's going downward, it is B cross A. Okay, when it B cross A, it is going downward. Okay, because you need to take the, you need to curl your fingers towards the vector B. Towards the vector A, from B to A. Or if the vector A is on the directions towards you, right? To the directions towards you. Okay, meaning that on the positive Z axis, right? So and then the vector B direction still remains similar, okay, between that axis. So you cross A to B and then you obtain the direction of the new vector going downward. Okay, you're clear? Okay, so this is what I just said. All right, this is what I just said. So A cross B is equals to minus B cross A. Okay. All right. So when it is minus B, so your B, let's say your B is to that direction. Okay. And then you can put that B on the other side. All right. When it's minus, so because B is going there, I mean, let's say towards you, and then minus B is reverse of that. So it's going there. It's going to the other side of the plane. And then minus B, so you got the, let's say your minus B cross A, it is similar right hand rule. So the direction is still going upward. Okay, it is still going upward. Example, it shows the direction of the vector B cross A. So that's why the thumbs is going downward. Alright. So when B cross A, the direction is downward. But when minus B cross A, it is upward. Because minus B cross A, it is similar to A cross B. Okay. I hope it's clear. So any concerns so far? All right. So we're going to the last one. So the last one will be the last slide for this chapter. Okay. So I hope everyone can follow me up to now, right? Because after this, it will be a more difficult topic. Okay. And then this is basically the basics of what you will learn later in the electromagnetism subject. Okay. PHY3401. Okay, now we are looking for the example on how to calculate the vector product. Okay. Give me a few seconds. You can see the video now.
Example 1.11. Example 1.11, we're going to find the cross product between a vector A, which has magnitude 6 units and is in the positive x direction, and vector B, which has a magnitude of 4 units and lies in the xy plane as shown here, making an angle of 30 degrees respect to the positive x-axis.
Okay, the information here, you have the 6 units of vector A, all right? And then the direction is on the positive x-axis, all right? And B is making angle of 30 degrees with that x-axis. Okay, so the vector B has a magnitude of 4 units.
We'll call the new vector formed by this cross product C. We have two ways that we can proceed. One is to only calculate the magnitude of C and then determine its direction from.
Okay, I have a question here. So what is the direction of vector C? What is the direction?
Upward.
Upward. Okay, so the direction of vector C is upward. All right. Okay, so let's continue.
The right-hand rule, and the other is to explicitly calculate the three components of C. So let's begin with method 1. The magnitude is easy enough to calculate. We have 6 times 4.
Okay. All right. Before that, okay, let me imagine this to you. Okay, the plane xy over here, xy is a vertical. All right, xy is vertical. Okay, so the y is actually upwards. Okay, actually the vector B drawn on the plane of xy is not on the plane of xz. Okay, so when B is on the plane of xy, so the vector C will be to the z direction. Okay, you look at the picture, vector C is to the z direction. Anyone confused with that? Are you guys confused? Or is clear? So A cross B, so you imagine that, so your x, okay, your x is to your left and then y to the north, all right? So your vector B is lying between that x and y, and A to the x direction to your right, okay, to your right, and then the vector C will be pointing towards you. Okay, so the vector C is pointing towards you, which is to the z direction.
The two magnitudes of A and B respectively, and the angle between these two vectors is 30 degrees, so the magnitude is 12. To get the direction, I place my hand, my right hand fingers in the direction of A, and then I rotate my palm such that it faces the general direction of B. Now my thumb, poking straight out from my hand, will point in the direction of C, which in this case will be along the positive Z direction here, as shown.
Okay, as he said, so the C is pointed out, okay, towards the z-axis. All right. So to find out the magnitude of C, all right, so you use AB sine phi. Okay. So to find out that, all right. So okay, let's see further.
So using this right-hand rule, I can write out C formally in unit vector notation, which is 12 units in the k-hat direction. For method 2, I'll have to do a little bit of work and calculate the components of each of these vectors by the usual method. Well, since vector A lies on the x-axis, its x component is 6, and its y component is 0. Vector B only has an x and y component. It has no z component, and here are its x component and y components respectively. Then I use these equations for the three components of the cross product, and again, I only end up with one finite component, and that's the z component, and I have exactly the same answer as I obtained with method 1. Which method you use depends upon the details of the problem. The advantage of method 2 is that you get the components directly without having to utilize the right-hand rule. And this ends example 1.12.
Okay, so basically it is clear that you have two ways to solve this problem. Okay, of course the method 1 is direct, is simpler. Okay, but for the method 2 is we are using the components. We are solving the components. We are dissolve that into the components, and then we find out what is the vector C. Okay, what is the vector C? All right, so hope that is clear for you. All right, so we're going out to back to the question of the tutorial. Okay, so it says here that we need to write each vector in figure 1.43 in terms of the unit vectors I and j. All right, so meaning that here it is similar like the components that we dissolve. All right, so for A, so what is I? What is A in terms of I and j? Okay, so A equals to 3.6 cos 70 I plus 3.6 sine 70 j. Okay, you got that?
Yes.
Okay, so that's the A in terms of unit vector I and j. So for B, so what's B? So Bx, so you minus, all right?
2.4
So, yes, 2.4, so it will
negative
minus, yes,
minus
minus 2.4
minus 2.4 cos 30.
cos 30, and then J will be minus
2.4 sin 30.
4 sine 30, yes. Okay, that's correct. Okay, so that's unit vectors. Okay, use unit vectors to express the vector C. Okay, where C is 3A minus 4B. Okay, so how do you solve for vector C? Okay, now you have the x components and also y components of A and B. All right, so you already have that. So it is easier because you already have A in terms of unit vectors I and J and of unit vector I and J. Okay, so what's the final answer for A? Okay, the final answer for A, it is 1.23i plus 3.38j. Okay, you all got that? 1.23i plus 3.38j. And then for the vector B, it is minus 2.08i minus 1.2j. Okay, everyone got that?
Yes.
Okay, good. All right, for B, so you multiply 3 with the vector A. So mean that 3 times 1.23i plus 3 times 3.38j. Okay, and then minus 4. Okay, for the vector B, you got 4 times minus 2.08i and then minus 4 times 2.18, sorry, minus 4 times minus 1.2j. Okay, so the final answer for C will be 12.01i plus 14.94j. Okay, so that's the answer for B. All right, and then for C, find the magnitude and direction of C. Okay, so you already obtained C in terms of I and J. So to find the magnitude, so because it's like I in the X direction and J in the Y direction, so you square that and then find the square root of that, so you get the magnitude of C. So meaning that C equals to square root of 12.01 squared plus 14.94 squared. So the magnitude will be similar to 19.17. Okay, 19.17, and the direction. So you need to find out what is the angle. So the y component of C is 14.94. All right, and then the x component is 12.01. So you find out the inverse tangent of that. Okay, inverse tangent. So meaning that tangent theta equals to 14.94 divided with 12.01. So the answer is 51.2. Okay, so that's for question 1.43. All right, so everyone is okay up to that question? All right, we move on to, because we already learned about the scalar product and the dot product and also the cross product as well. So I think it will be simpler for you to solve for 1.46 and 1.51. Okay. So for 1.46, find the scalar product of the two vectors A and B. So vectors A and B is already given in terms of the unit vector. Okay, so you just do the dot product. So when the dot product 4 will be times 5. Okay, 4 times 5, the answer 20. All right, plus is 7 times minus 2, which is minus 14. So 20 minus 14, it will be 6. So that's the answer for A. Okay, answer for A is 6. And then what's the angle? So the angle, as usual, you find out x and y component. Right? So for the angle, either you find the component or you have that equation AB cos phi. AB cos phi is equals to the dot product of A and B. Okay, so basically you need to solve what is that phi to find the angle. Okay, so there is another method. You can also use the component. All right. So it will be similar way to solve, but the easier way is you use directly the formula of AB cos phi. So you solve cos phi, right? Because A dot B you already obtained, right? Cos AB cos phi equals to 6, right? And then cos phi equals to 6 over AB, right? So what is your A? So your A, so the magnitude of A, of course, will be the square root of 4 squared plus 7 squared, which is equals to 8.06. Okay, and then what is B? So B is also similar calculation, is equals to 5 plus minus 2 squared. All right, so B is equals to 5.39. Okay, so B is 5.39. Then the final answer will be, so because it is cos phi equals to 6 over AB, so you already obtained is 8.06 and B is 5.39. So cos phi equals to 6 over 8.06 times 5.39. Okay. So finally you got phi as 82.1. All right. So that's for B. And for the last one, 1.51. Okay, you need to consider back figure 1.43. So we are finding out what is the scalar product A dot B. So A dot B is equals to AB cos phi. Okay, AB cos phi. So it is equals to, what is the cos there? What is the phi? So you have, okay, this is 90 degrees, so it will be 20 plus 90, so it's 110. 110 plus 30, so it will be 140. So cos 140, and then what is A and B? So A is already given, the magnitude of that, 3.6 times 2.4 cos 1. So the answer is minus 6.62 meter squared. Okay, so that's the answer for A. But it will be in the direction of, okay, it will be in the direction of negative. All right, because cos 140, you obtain the negative result. Okay, and then the last one, find out what is the magnitude and direction of the vector product. So the scalar product, the cross product, A cross B, okay? So A cross B, AB sine phi. So sine, so phi is similar, 140 degree. Okay, 3.6 times 4 sine 140. So the answer will be 5.55 meters squared. All right, so that's it. Okay, so you already finished with the chapter 1 tutorial. Okay, so you need to turn in your submission by next week. I will open up the link on the Putra Blast later. I will open up within this week. Okay, maybe the end of this week. So you will be able to do the submission soon. Okay, so try to complete all that assignment. So it will be due before the next lab session. Okay, any questions so far? So before I stop with today's session.
No, doctor.
Okay, it's good. So everyone is clear what is learned today. So I hope everyone already know how to find out the unit vector, how to find the scalar product, how to find the cross product, okay, and how to do the unit conversion, okay, and also how to solve for the vector components. Okay, so that's basically what is learned today. Okay, so turn on your camera. So let's take the picture for today's session. Okay. So let's me do the countdown. 10, 9, 8. All right, 10, 9, 8, 7, 5, 4, 3, 1. Smile, everyone. Okay. Okay, one more. Okay, thank you. All right, so I hope you enjoy today's tutorial session. So for the next week, so we will start with our first lab session. Okay, if you have any concern after this, so let me know. Okay. So I see you on Thursday. All right. Okay, so hope everyone is are able to solve the tutorial question for today. So thank you. So I see you again on. Okay, bye bye. Assalamualaikum.
Waalaikumsalam. Thank you.
Waalaikumsalam.
Thank you,
Thank you,
Doctor.
doctor.
Thank you, doctor.
Thank you, doctor.